the probability distribution for the discrete data, right? Can you all see the slide? Can you all see the screen?
Yes, sir.
Right, okay. So today we are going to talk about discrete probability distribution, how the probability distributions will look like for discrete data. We already said what is discrete data, what is continuous data. Right, probability distribution. We have already defined that. Anyhow, we will define once again. The probability distribution for a random variable describes how probabilities are distributed over the values of the random variable. So how these values, probability values, are distributed for this random variable. That is basically called as probability distribution. We can describe a discrete probability distribution in the form of a table, graph, and equation. This information we have said last time also. The probability distribution can be expressed in terms of table or graphical form or equation form, right? We will see all three types here in our course. Right, the probability distribution is defined by a probability function denoted by fx. So fx means it is a probability function, right? Probability function. We can express any distribution using fx, function of x. Fx means it is function of x, right? So function of x, which provides the probability for each value of the random variable. So that is important. So so this is fx is called as function of x. So here the probability distribution function that we are going to denote it using fx, right? Giving the name of the function. Right. So once you look at this discrete probability distribution, it has to satisfy some of the conditions, right? Under the discrete probability functions. Let's say these functions, probability functions, should have a probability equal or above 0. So the probability values should be always equal or greater than 0, right? Similarly, if you add all the probability functions, how do you call this notation? How do you call this notation?
Summation.
Summation. Summation of all probabilities, it should be equal to 1. So it should fulfill the requirement of this. Any discrete probability distribution will adhere to these conditions. So the probability values are higher than or equal to 0. The total probability is equal to 1. Meantime, we can say, rather than saying here, the probabilities are greater than or equal to 0, but less than or equal to 1. We can say like this. The probability of a function should be equal or greater than 0, but equal or less than to 1. So this is more appropriate. You can write down this, right? So it is giving only one condition. This is giving two conditions. It is greater than or equal to 0, but less than or equal to 1. Okay. Right. Now, if you talk about further on discrete probability distribution, Right. This is an example. This is an example. Could you remember last time we talked about selling TV on a particular stall or particular shop, right? We will look at the same example using the past data on TV sales. A tabular representation. I mean, tabular means it has been already arranged for us of the probability distribution for TV sales was developed, which is given below. So we try to explain that table. It is not very complicated table. It is a very simple table. You see, in a year, keep in mind, in a year, they have simply taken how many days that they sold in a year. Zero number of TVs. In a year, how many days that they sold zero number of TV. That means they didn't sell anything. How many days? 80 days. 80 days in a year, they have sold zero number of TVs. 50 days out of 365 days, they sold only one TV. Out of 365 days, 40 days, they sold two TV, that particular shop. Out of 365 days, 10 days, they sold three TVs, and out of 365 days, 20 days, they sold 40. Is it clear? Is it clear? The table, is it clear? Arosha?
Yes, sir.
Right. It's clear. It's very easy. Right. Now tell me, what is this 200? What is this 200? That is the total number of days. What do you mean by this 200? Can somebody explain? What is this 200?
Sales days.
I couldn't hear Arosha. Once again.
Sales day. The dates where shop was open.
Ah, good. Right. So actually, if you accumulate all these value of number of days, it says it is 200. So what is this 200? This is actually out of 365 days. Out of 365 days, the shop was open only for 200 days. So out of 200 days, this is the structure, how the TV has been sold, right? Why we call this as a discrete data? Can somebody explain why we call this as a discrete data? Can somebody explain why we are calling this as a discrete data?
No any decimal
Between values.
Yeah. For example, can I ask a question? So zero number of TV sold is possible. One number of TV sold is possible. Two number of TV sold is possible, and so on. Can I ask 0.5 number of TV sold in the shop? Or can I ask 1.2 number of TV sold in the shop? Will it possible to ask that question?
No.
No, it is not possible. So the number of units sold is decimal, no decimal point at all. Those are full numbers, no in between values. So that is why we call them as a discrete data, right? Right. Now we have gone one step ahead here. right? The same x values 0 to 4, you could see. This is called as discrete random variable. Discrete random variable. What do you mean by discrete random variable in this particular example? Number of TV sold per year. Number of TV sold per year. For how many days? Number of TVs sold per year. So that is my discrete random variable in this example. 0 number of TVs, 1 number of TV, 2 number of TV, 3 number of TV, 4 number of TV. So no more, not more than 4 number of TVs have been sold. So maximum number of TVs sold is 4. Right? Right. Now simply we are looking at the probability. So these are the probability function. Can you remember we talked about this, the probability function fxi, right? Sometimes this probability function we write it as, in certain cases, pxi. Same thing. pxi. So how do we calculate the probability? This is 0.4. So how this coming? So that is equal 80. That is the total number of days 80 for selling 0 number of television divided by total number of days that shops has been open. So 80 divided by 200. Similarly, in this case 50 divided by 200. Right? What about this? Peony, what is the value of what is the
probability? 40 divided by 200.
Yeah, 40 divided by 200, right? Right. So similarly, this is 10 divided by 200. This is again 20 divided by 200. So look at the probability, total probability. What is the total probability? If you add all these values, that is equal to 1. So it is same as what we said already. Total probability is equal to 1. This is a simple example, right? Very simple example. If you plot them, you see, if you plot them, so we are going to plot these values. If you plot them, that is actually called as probability distribution, right? Earlier we said this probability distribution can be given in terms of table. Probability distribution can be given in terms of table. So this is actually probability distribution in terms of table. Now, similarly, we can say probability distribution in terms of graph. In terms of graph, what did we do? We simply drawn the same values, nothing else. So this is the x values, discrete random variable, possible values of discrete random variable 0, 1, 2, 3, 4, and their respective probabilities. Right? Simply we have drawn all the probabilities to indicate. So if you just connect it, this is the distribution. Looks like. This is how the distribution looks like. Right? Actually, you don't need to connect it, but if you simply draw it, this is what we say distribution, but by graphical representation. Clear? All right. Is it clear? Okay. Right, let's move to the other slide. Expected value. Expected value and variance. So here in discrete probability distribution, we have two things that we can calculate. One is called as expected value. The other one is variance. Expected value and variance. So this is expected value and the variance. So the expected value or the mean. So usually in discrete random variable, we don't call it as mean. It is, but it is same. Expected value and the mean are same in discrete random variable. So expected value or the mean of a discrete random variable is measured, right? As you all know, usually it is giving the middle location or the central location, right? So this is how we indicate by notation expected value. So expected value of x is equal mu. This is what we have already learned. What is this mu? How do you call this mu in the introduction of mu? Yeah.
Population mean.
Yeah, population mean, similar to that, right? So mu, here in this case, we use the term expected value of x, which is mu is equal summation of x multiplied by, summation of x into fx. We will learn this with example later. So this is actually x in x mean it is the random value multiplied by their respective probability, right? Plus this is, let's say, for x1, for x2, this is plus, right? So another term, it says summation of x into fx. So this is what the expected mean or expected value of x is, right? So this is actually, we have a table. Can you remember in the table we have x and fx? So 0, 1, 2, 3, 4. So what are the values here? I can remember. This is 0.4, right? What is this point?
25.
25.
0.2.
0.2.
Yes.
Okay, this is 0.05. This is 0.1. Okay. So this is total value is 1. So now, how to calculate the expected value? You multiply each of these components. So 0 multiplied by 0.4 plus 1 multiplied by 0.25 plus 2 multiplied by 0.2 and so on. So this is actually what we said, the expected value, right? So the expected value is calculated as such. Clear? Right. So that is our expected value. Now we want to calculate the variance, right? We want to calculate the variance. Expected value is similar to the mean. Variance is as usual. Variance summarizes the variability in the value of random variable. So it's variable we write as variable of x, which is similar to sigma square, population variance. Can you remember? So this is the formula that you should remember. That gives summation x minus mu whole thing square into fx. So that is so that is variance of x is given as summation x minus mu whole thing square into fx. Right? So here we know already where we can get the mean. With the formula summation x minus mu whole thing square into fx. So what is this? That is actually expected value of x. Isn't it? This we have already calculated into x. Isn't it? This mu is expected value. Right. Later we will see how this could be calculated. All right. So keep this formula in mind. What is standard deviation? Standard deviation is simply take the square root of variance of x, which is standard deviation. Right? That is always true in any cases. Standard deviation is true in any cases. Okay? Right? Right. Now, for the same example, let's calculate the expected value as well as the variance. So expected value, as I pointed out earlier, it's very easy. Multiply these two. That is given there. Right? Multiply x and fx. That is there. Multiply this. That is there. So if you add all these value, that is your expected value. So your expected value is 1.20. 1.20. Your expected value is 1.20. Right? How we can interpret this expected value? How we can interpret this expected? Anyone who can explain that? How we can explain the expected value? It is the expected number of TV sold in a day from that particular shop. On an average, that particular shop is selling 1.2 television per day. So you see, on an average, that particular shop is selling 1.2 televisions per day. Is it clear? Is it clear? Yeah. So that is how we interpret the expected value.
So,
Yeah.
so the expected value is 1.22, no?
1.2. Yeah.
So that is Is that is possible 1.2?
Yeah, because this is we are taking the average.
Okay.
Average, we are taking average because even though discrete variable, so we said the discrete variable, the random events that occurring is discrete. So this is discrete, no problem with that. So no in between values. But when you take the expected value, definitely it will, I mean, most of the time it will come in decimals. So we say this particular shop is selling roughly 1.2 a number of televisions per day. So that is possible. Okay, that is possible. But when you say discrete, here, if you take the original data, raw data, here we cannot have any decimal points, right? This is a calculated one, isn't it? We are doing some calculation.
Yes.
This is not calculated. This is observed value. This is based on the observation, isn't it? That is based on the observation.
Yes.
So in this case, under the observation, you cannot say the decimal values, but in the calculation, decimal values are possible. Okay, right, good. Okay, so this is how we can interpret in this example. 1 point on an average, this particular shop is selling 1.2 televisions per day. Right, let's look at how to calculate the variance and the standard deviation. We know the expected value is 1.2, so that we'll have to keep in mind. We can calculate in a simple form. I am putting everything at once, right? So the first information that we'll have to calculate is the deviation from the expected value, right? According to the formula, 0 minus 1.2, 1 minus 1.2, 2 minus 1.2, 3 minus 1.2. So this is x minus mu. Mu mean, this mu mean it is the expected value. Then you sky it up. So you have this information. Then you have this fx, that is the probability function. Probability function. Okay, so this probability function can be multiplied by this. Multiply this component. So we will end up with this value. So you add all these value. If you add all these value, you end up with this value. Right? So add all these value, you will end up with 1.66. So variance of daily sales in that particular shops is 1.66. But what is the unit here? It is the TV square. To get rid of this square, what we do? We look for standard deviation. We look for standard deviation. So if you take the square root of this 1.66, you will end up with 1.2884 televisions. So the standard deviation of daily sales can be expressed as 1.2884 televisions. Right? So this is how we can interpret the variance and the standard deviation. Right. Now we will take another example. Another example for discrete random variable. Have you seen a die? Have you seen a die? Yes or no?
Yes.
Yeah. Maybe during your childhood time, you could have played this Ludo. How many faces are there?
6.
Yes.
6.
6 phases, yes. Ludo has 6 phases. So each phases have been numbered from 1 to 6. Each phases has numbered 1 to 6. So what are the possible outcome when you throw a Ludo or the die? When you throw a die, what are the possible outcome? How many phases are there with numbering? What about 0? 0, is it possible?
6.
0, does it possible?
No.
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 0. So, what is the minimum value possible?
1.
1.
What about 2, 3, 4, 5? What is the highest number possible?
6.
6. The highest number of, highest number possible is 6. The lowest number is 1. So this is the probability function. So we can write it as such also, right? These are same. These are same. Right? Probability function can be written as probability function can be written as fx or pxi. So certain books they write it as probability density function. We will come to that later. Sometimes in my text also you might have seen pxi also, right? So fxi. So what is the chance of getting 1 when you throw a die? What is the chance of getting
1 over 6.
1 over 6? Why? Because we have 6 phases. So there will be only one phase indicated as number 1. So the probability is 1 over 6. So which is true for all other cases. Right? Okay. Now we'll go back to the graph. So this is the table explanation when you roll a die. This is a graphical explanation. Graphical explanation is you can have 1, 2, 3, 4, 5, 6 are possible. All are having same equal probabilities. If you add all the probabilities, that is equal 1. So this is what I have already given to you. This is in terms of table form, right? So you see now we are talking about px. Same thing, right? Fx or px are possible to indicate the probability function, right? Those are probabilities. Those are probabilities. Sometimes we call as probability mass function, right? Or probability function. All are same, right? Probability mass function, probability function. Right. Now what we do is this is a cumulative probability function. What do you mean by cumulative? Look at here. Cumulative means you add the value. So this plus this first. In the first instant, this value, this add. Then you add these two with this. Then you add this one with the above 3. Then you add this one with above 4 events. Then at last you add this one with all the above events. So that is called as cumulative density function. So this is giving a cumulative density function, or you can call it as cumulative distribution function. Both are same, cumulative density function or cumulative distribution function. Right? Okay. So these are adding. Each probability will be added. Can you remember in the frequency table we said less than cumulative density function? Less than or give, greater than or give, similar to that. So this is actually showing a less than or give. So once you get the highest value, which is equal 1. Right. So this is cumulative distribution function. Probability of x less than a. What is the probability of getting, right? So we will look at the first thing. What is the probability of, in the cumulative density function, we can find out what is the probability of x getting less than or equal 1. That is equal 1 over 6, isn't it? What is the probability of getting x less than or equal to? So we'll have to add the probabilities of these two to get the value of this. So here 1 over 6, here 1 over 6, so 2 by 6. Similarly, what is the probability of getting x less than or equal to 3? Then we'll have to add the probabilities of these three, less than 3. So that is the value there. So 3 divided by 6 and so on. Anyone couldn't understand what I am saying? Anyone need explanation? So this is looking at the probability less than a particular value. So now, if I ask you a question, what is the probability getting a value 1? Yoshini, what is the probability getting a value 1 in this example? Yoshani, what is the probability of getting in this example 1? What is the probability of getting 1? Yoshani, are you around? Yeah. Kirija?
Yes, sir.
Yeah. Can you tell what is the probability of getting 1?
1 over 6.
1 over 6. That is good. Right. Now, I am going to ask, what is the probability of getting 1.5? What is the probability of getting 1.5?
No chance to get 1.5.
I couldn't hear Kirija. Kirija, louder. But I'm asking, earlier you answered correctly. The chance or the probability of getting 1 is equal 6, 1 over 6.
Yes,
That is
sir.
correct.
There is no chance to get 1.5.
So what is the answer for that?
0.
0, good. So here, if you ask what is the probability of getting 1.5 in this example, because as we said, there's no any in-between numbers possible, right? So if I ask you what is the chance of getting, or what is the probability of getting 1.5, the value is 0.
0.
Yeah, good. Value is 0. So this is the speciality of discrete random variable. So they have exactly the probabilities. There's no any in-between probabilities. So they have exact probabilities. So this is called as point probability. Point probability. Write down correctly. Eh? Point probability. So this is called as point probability. Each of these cases, point probability. Why? Because there is no any probabilities in between two values. Right, good. Right. Question number 1. Anyone can answer. If you toss a die, what is the probability that you roll 3 or less? Can somebody ask? If you toss a die, what is the probability that you will get 3 or less? You have already done that.
1/2.
1/2. So this answer is correct, right? 1/2. Right. What about this question? Now we are tossing or throwing 2 dice. Similar, balanced 2 dice. Is it clear? Are rolled and the sum of the space value is 6. What is the probability that at least one of the dice came up a 3? Right. Before talking about the question, now before talking about the answer, we will look at the question. How many dice are we throwing now? 2 dice. Die 1, die 2. So from die, you have all possible values. From die 2, also you have all possible values. So the question is the addition of the numbers of these 2 dice. So what are the possible values? Those are the possible values in the event. Anyone? What are the possible values when you add these numbers? Minimum value?
1.
Minimum value? Arosha, what is the minimum value?
1.
1. Is possible? 1 is possible because I am throwing 2 die. So what is the minimum possible on die number 1 is 1. Die 2 is 1 again. So if you add these 2 values, it is 2. So 1 plus 1, this is 2. That is your minimum value. You have 3, 4, 5, 6, 7, 8, 9, 10, 11. What is the maximum value possible? 12. The maximum value possible is 12. Do you understand? So 2 is minimum value possible, maximum is 12. Clear? Can you find out the probability for each of these? Can you find out the probability for each of these? Do it now. What is the probability for the first one? Can somebody tell me what is the probability for getting 2 when you draw 2 dice?
1 over 6.
1 over?
6.
No.
1 over 11.
1 over?
1 over 36.
1 over 36.
1 over 16. 1 over 16.
1 over 16. Right. If it is 1 over 16, just multiply by 2 and tell me what is the value.
2 over 36.
2 over 36. That is correct. 2 over 36. How? So you can put a matrix. Let's say die 1, die. So 1, 2, 3, 4, 5, 6. Right? 1, 2, 3, 4, 5, 6. As an example, right? So you can write down. So here 1, 1 possible, 1, 2 possible, 1, 3 possible, 1, 4 possible, and so on. Right? So somebody said, how many events are possible? How many events are possible? What is the total number of events?
36. 36.
36. Right. So 36. 36 events are possible. So how many times you get 2? Is it 2 times or 1 time?
1 time.
1 time? Are you sure? So this is the time that you are getting 2. How many times you are getting 3? This is 3, isn't it? This is also 3. How many times? You get 3.
2 times.
How many times you get 4 addition? 4 is, this is 4, this is 4, this is 4. What else?
3 times.
Yeah, 3 times. Right? 3 times. What about 5? What about 5? How many times? Anyone? You can
4 times.
4 times.
4 times.
1, 2, right? 1, 2. Then this is 3. Okay. 4 times. Then what about 6? Sorry. Yeah, 6. Total of 6. 1, 2, 3, 4, 5. 5 times. Isn't it? Then what about 6? What about 7? 1, 2, 3, 4, 5, 6 times. Right? What about 8 times? I mean 8 value. What about 8 value? Can you fill the rest? Can you fill the rest? You will see a pattern if you fill the rest. What about getting number 8? How many times?
7 times.
Yeah,
7 times.
1 time. You try.
7, 7.
Are you sure? No, number 8. Can somebody find out?
5 times.
Huh?
5 times.
Five
Five times.
times. Yeah, 5 times. You will get 5 times. You will get number 8 5 times. What about number 9?
4 times.
4 times. You see now it has increased, then it is decreased gradually. It becomes as a symmetric. That is a specialty of this kind of binomial distribution. So without looking at that, we can answer looking at this table. So how many times, what is the value of 10? How many times you are getting 10? 3 times. This will be 2 times. This will be 1 time. So you see, from this it is symmetric. So that is the specialty of this binomial. I mean, this discrete distribution. We'll come to that the name later on. It's actually binomial distribution. We will come to that later. Right now, can you answer that question? When 2 dice are rolled and the sum of the face value is 6, right? Sum of the face value is 6. What is the probability that at least one of the die came up a 3? You understand the question? So the question is, the addition of value is 6, right? The addition value is 6. So how many times we are getting 6? How many times we are getting 6? 5 times, right? Out of this 5 times, the question is ask die 1 and die 2. One of the die is having a value 3. So if this is having a 3 value, to add to come to 6, what is the value of the die 2 should be? 3. How many times we are getting 3, 3? That is the question. Out of this total value that you are obtaining 6. So what are the possible combination for die 1 and die 2? 1 and 5 possible to get 6. What are the possible other ways? 1 and 5, you see? 1 and 5, right? 2 and 4. What are the other possibilities? 3 and 3. Then, yeah, 4 and 2. And 5 and 1. Die 1 and die 2. These are the possibilities. Isn't it? How many possibilities are there? 5 possibilities. So that is why you have 5 possibilities out of 36. So now the question is, out of this 5 times, how many times they are coming as 3 from one die? If it is 3 from one die, the other die should have a value 3. So this answer is 1 over 5. The answer is 1 over 5. Out of 5 times, you are getting 1 time only 3 on a die and 3 on the second die. So the answer is 1 over 5. Is it clear? Is it clear? So this is, you have already the answer here. How can you get 6 on 2 dice? 1, 5 and 5, 1. That is the first digit indicate the first die, second digit indicate the second die. these other possibilities. I have already mentioned that. One of these having 5, one of these 5 has 3, so that 1 over 3. Sorry, 1 over 5. The answer is 1 over 5. So that is the answer. Is it clear? Right. Some practical problems. You can look at it. The number of patients seen in an emergency room in a given hour is a random variable represented by x. The probability distribution x is given as such. So this is, I mean, we can apply this discrete to any situation. So in an emergency room in a hospital, let's say the number of patients seen 10 number of patients, 11 number of patients, 12 number of patients, 13, 14, right? Only they have restricted to 5 numbers. So these are the probabilities that they can have. 0.4, 0.2, 0.2, 0.1, 0.1. So if you add total probability, it should be equal to 1. Otherwise, something wrong. So here also we have total probability is equal 1. 1 over 36, 2 over 36, 3 over 36, and so on. Right? So the probability distribution is given there. Find the probability that in a given hour, so it is in a given hour, right? In exactly 14 persons arrive. So what is the answer for the first one? A. Anyone?
1.1.
Yeah, 0.1, not 1. So our question is probability of x equal 14. So this is my question. So exactly 14 is there. So that is equal 0.1. What about second question? At least 12 patients arrive. So if you put it in formula, how we can write? Probably x. Anyone? At least, minimum. How can I write? At least 12 patients arrive. So x less than or equal 12. So if it is less than or equal 12, so that is equal probability of x equal 12, right? Plus probability of x equal 11 plus probability of x equal, in this example, 10. Can you add all the probabilities together and give the answer? So this
0.8.
0.8, yes. Add all these probabilities, at least 12%. So the answer is 0.8. Right. So the next question is, at most 11% arrive. So what do you mean by that? So this is the answer I have already given. At most 11 patients arrive. So what does it mean? Anyone?
Sir,
So in question B,
Yeah.
answer is 0.4 now.
hello.
Yeah. Yeah.
Sir, at least 12 patients means 12 is the minimum.
Sorry, at least 12. Yeah, you are right. You are right. You are right. Because I was thinking the less than 12 patients. So at least 12 patients mean you are right. This is minimum 12. 12 and above. So you are right. Right. So I was thinking this is the maximum 12. So minimum 12. Right. Okay. minimum 12, so that you'll have to add the values of, let's say, these three values. So probability of x greater than or equal 12. So we'll have to add this plus this plus this. Right? Right, good. Right, what about the next one? At most 11 patients arrive. So in that case, other way around, as I put it earlier. So it is the maximum value is 11. The minimum value is less than that. So what is the maximum value? Maximum value is 11. So the probability is of 11 and less than 11. So we'll have to add these two probability for that. So the answer is 0.6. Right? So by giving the question, you may be able to find out the values easily, right? Similarly, if I say in this die example, if I say find out the probability, can you see the board? Can you see the board? Yes or no? Can somebody answer me? Can you see the board?
Yes.
I mean, what I have written, can you see?
Yes, sir.
Right. Can you find out the probability of x greater than or 9 in our case? Tossing two dice or throwing two dice. That is equal, adding the probability of x equal 9 plus probability of x equal 10, probability of x equal 11 plus probability of x equal 12. So if you add all these values, that is 1 over 30, sorry, not 1 over, 4 over 36 plus 3 over 36 plus 2 over 36 plus 1 over 36. Can you see the board? Yes or no?
Yes, sir.
Can you see the board? Answer.
Yes, sir.
Yes, right, okay. Right, so that is how you should be able to find out the probabilities, cumulative probabilities for any questions that has been asked. Right? Okay. So these are the answers. Then we will move to the other one. Right, now we have introduced the discrete distribution, probability distribution. Now under that, can you remember last time we said under the discrete distribution, there are two types of distribution that we are going to discuss. One is called as binomial distribution. What is the name of the other distribution, discrete distribution that we are going to discuss? Anyone? It is in your notes. Last time I have shown you.
Poisson.
Yeah, Poisson distribution. Right. We will see that also. First, we will see binomial distribution. Actually, we have introduced that term binomial already. Let's look at binomial distribution. It is a discrete distribution. 4 properties of binomial distributions are important. The experience consists of a sequence of n identical trials. So, when you say tossing a coin 3 times, that means every time they are identically tossed. No any biasness coming into play. So identical tossing a coin. We might take an example on tossing a coin as well. A simple example. So the trial is identical. The number of time that we are tossing or number of time that we are rolling die is identical. So no biasness involved. The second property, 2 outcomes are possible. Success and failure. Right? Success or failure are possible on each trial. For example, tossing a coin. What is the two outcome, possible outcome? Anyone? Tossing a coin. If I toss a coin, getting a head or not getting a head. Two outcomes: getting a head or not getting a head. Or getting a tail or not getting a tail. Is it clear? So this is called as two outcome. Right. When you throw a die, how many faces are there? 6 faces are there. 1, 2, 3, 4, 5, 6. So if you throw a die, I can have an objective. Based on that, we can say success or failure. So my objective is getting number 6, face number 6. Or what is the opposite of that? Not getting number 6. If I toss if I draw a die, what is the chance of getting number 6? If I throw a die, what is the chance of getting number 6? Face number 6?
1/6.
1/6. Good. Now, what is the chance of not getting number 6?
5/6.
Exactly, 5/6. So this is called as the outcome. This is called as the success or the failure. Clear? Right. The probability of a success usually denoted by P. So hereafter we are going to use the probability as P. Right? Probability of success denoted as P does not change from trial to trial. So this probability of success, which is denoted by P, will not change from trial to trial. So we have already discussed about this trial, identical trial. So it's not changing from trial to trial. So it is a stationary assumption. This is a stationary assumption. So these are very important properties. What is the fourth property? The trials are independent. That is also very important. So these are 4 basic properties of the binomial distribution or binomial experiments. So binomial distribution, our interest in this number of success occurring in n trials. For example, number of success occurring in n trials. We let x denote the number of success occurring in the n trials. So this is basically the random variable, discrete random variable, which is x, denote the number of success. Usually we take number of success as the x. You can take it other way around as well. Usually what we do, take x as the number of success, which is the random variable. Right? We will see the examples later. So binomial probability distribution, a fixed number of observation of trials, which is n. Examples, you are tossing a coin 15 times. You are tossing a coin 15 times, right? Sorry. You are tossing a coin 15 times, right? That is one example. So number of a fixed number of observation in trials. So this n is 15. In this case, n is 15. N is 15. So if you take another trial, getting 20 patients, getting 0 patients, 1 patient, and so on, 20 patients. So that is n is 20. Here n is 1,000. So likewise, we can have any number of n's, but it is a fixed number. N is a fixed number. A binary outcome. Binary. What do you mean by binary? We have already said 2 outcome possible. Binary outcome, right? 2 outcome possible. Success or failure. right? So example, head or tail in each toss of a coin. Having diseases or not having diseases. Let's say if you are doing some research in whether the plant is resistant to a particular disease. So you are looking at the plant and you are having a record whether that plant is resistant. So whether that plant is resistant or not resistant. That means susceptible. So two outcomes are always possible. So that is called as binary. So in statistics, we call it as binary, that is two outcomes. Generally called as success or failure. As I said, probability of success is given always with a P. Probability of failure, because total probability, as you all know, 1. So if the success is P, the failure is 1 minus P. Could you remember I said getting number 6 is 1 over 6. In a die, getting number 6 is 1 over 6. Now, not getting number 6 is 1 minus 1 over 6. So what is 1 minus 1 over 6? Somebody has already answered. That is 5 over 6. So that is how this will work. Any questions? Anyone would like to answer or ask questions? Who is that? Sahala? Are you around, Sahala? 1093. Sahala? Are you around, Sahala? Sahala? Can you hear me? Sahala? Senuri? Senuri, are you around? People are missing. Huh? Senuri? Sahala, are you around? If you don't answer, I will just remove from the connection. Huh? So you'll have to answer whether you are wrong or not. The answering will not be a problem. You will have to always answer. Doesn't matter whether it is wrong or right. This is a learning phase by everyone. Sahala, are you around? Sahala, are you around? Senuri? Yes, Sahala. Senuri, yes. Now only you are unmuting. Yes, answer. Sahala.
Sir.
Sahala, I couldn't hear anything. Yeah? Sahala, you can answer in any language. Sahala. I don't hear anything. Huh. Senuri? Senuri? Tilini? Rajapaksa?
Yes, sir.
Yeah. So, did you understand what we are discussing, or do you have any clarification or doubts?
Understand.
Understand, right? Good. Okay. Right. The other character of this distribution is constant probability for each observation. So that is also possible. Constant observation for each, constant probability for each observation. Example, probability of getting a tail is the same each time we toss a coin. So when you toss a coin, what is the chance of getting a tail? Usually if you toss a coin, what is the chance of getting tail? 0.5. Chance of getting tail is 0.5. So if you toss it tomorrow, what is the chance of getting tail again? 0.5. That does not change. That does not change. Okay. So getting the probability at each observation will be same. Right. Now we will look at some tossing a coin. Take the example of tossing 2 coins. Right. What are the outcomes? What are the outcomes? So coin 1, you get a head and tail. From coin 2, again you get a head and tail. So what are the possible outcomes? So this is coin 1, first one is coin 1, second one is coin 2. So if you take cross, so head and head is possible, so that is there. Head and tail is possible, that is there, second one. So tail and head, that is the third possible outcome. Tail and tail, that is the fourth possible outcome. So 4 outcomes are possible. Head and head, head and tail. Tail and head, tail and tail. When you toss 2 coins, right? Head and tail and head. Okay. Right. When you toss 2 coins, that is fine. So this is the outcome. Anybody couldn't understand the concept? So basically, we can put it a diagram like this. When you toss a coin first time, you get a head and tail. Then again, this is the first stage tossing. The second stage, if you toss again for the second time, you can get a head and tail. So you can put a pedigree structure like this also. So what are the outcomes? This is the first outcome. Then you have the second outcome, third outcome, and fourth outcome. Right? So that is the possible. So this has a special name called as sample space. Sample space. So when you write all the possible outcome, then it is called as statistically sample space. Right? Let X, that is the random discrete random variable, number of heads. When you toss number of heads. So how many number of heads are possible in this case? Let's say X. This is X. How many number of heads are possible? 0 number of heads possible. 2, 1 head is possible. 2 head is possible. Maximum 2 head. Why? We are tossing 2 coins. So probability, I will write it as P. What is the probability of getting 0 number of head? Anyone? What is the probability of getting 0 number of head? So here we have head, here head, here head, here head. Here, Priya and Jenny? Yes?
1 by 4.
Yes, 1 by 4.
1 by
Yeah, good. 1 by 4. So getting no heads, because we are talking about heads. Why? Our random variable is defined as number of heads. So getting no heads, so 0 number of heads is 1 over 4. Getting 1 number of head, what is the value? So here this is possible. This is only 1 head. This is also only 1 head. So what is that? 2 by 4. Getting 2 heads, again, both will be head, that is 1 by 4. Right? Is it clear? That is how it works. I think on the other side it may appear. Yeah, it is there. Probability structure. So this is called as In a binomial distribution, if you have the x value, possible x value, that is called as events. Possible x value, that is called as events. Similarly, the probabilities, which is called as pxi. In a binomial distribution, probability is given as pxi. The events is given as xi. So when x equals 0, when x equals 1, x equals 2. So these are the probabilities we have already discussed. Now we come to a little bit complicated, tossing 3 coins. 3 coins tossed. So you can put a tossing, this is the first toss. Second toss, again HN T. Here also HNT. Again, here you can fill the rest. Very difficult to draw here. So you see 3 stages. First stage, second stage, and third stage. 3 tosses. So you can see the first stage H, 3 H's. So that is first one, second one, and so on. How many outcomes are there? This is the sample space. This is the sample space. So what is, how many outcomes are there? 8 outcomes, right? So now number of heads again as the random variable x. So we can say 0 number of heads, 1 over 8. So we can count how many having 0 number of heads. Then 1, it is 3 by 8. 2 heads, again 3 by 8. And 3 heads, so 1 by 8. You can read it. So these are the outcome, possible outcome for x. So this is called as a discrete variable. So what about getting 1.5 head? Can we get 1.5 head?
0.
No. Yeah, it's 0. Getting 1.5 head is 0. Right? Right. Any questions? So this is your homework. Take the example of 5 coins. What are the probability that you will flip exactly 3 heads in 5 coin tosses? You give the probability structure. So give a probability structure as such. All right. Find out the probability structure, then you answer that. This is a homework. Right? Okay. I think you have already in printed form. Right. Further, I have already done this, right? One way to get exactly 3 heads is what is the probability of exact arrangement? Yeah, you can use the formula, right? As I pointed out earlier, what is the probability of this exact arrangement? So how do you get 3 heads, right? One way to get 3 heads is this. The other way getting 3 heads is, what are the other possibilities? Because this is one way. Another way is, for example, T, H, H, H. So this is also, you have 5 tosses, right? We have 5 tosses. Out of 5 tosses, first 2 tosses you have tail, second, third, third, fourth, and fifth tosses are head. So this is also one way to get the exact 3 heads. So how we can find out this? So probability head, 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 tail, tail. That is equal, head, head, head. That is equal. How many times we have head? 3 times. So half, getting 1 head in a toss is half probability to the power 3 into getting the two tails. So if you multiply, you will end up with the sorry, the answer. So this is another way, right? So these are another way to get the probability of the outcome. So you will have to write down the probability of each and every possible ways of getting head. So this is one way. I have written another way. This is a third way. So likewise, there are so many ways. So their respective probabilities you can calculate. So this is half to the power, because half to the power 1 into half to the power, or you can say half to the power 2 into half to the power 3. So that is also same. Right? So in fact, half to the power 3 into half to the power 2 is the probability for each time when it occurs 3 heads and 2 tails. So how many times it occurs, that you'll have to calculate. Right? How many times it occurs, overall probabilities, how many times it is occurs, right? So this is the first time, this is the second time, this is the third time, and so on, so on, so on. How many times unique arrangements as there are, but how many are there? So we'll have to find out. Maybe you, I don't know whether it is available. Right, it is available already. So there are 10 arrangements in this example. So each of have the same probability, half to the power 3 into half to the power 2. So if you add all these probability, right? So 10 times, this x is 10 times. So 10 into half to the power 3 into half to the power 2 will give the answer, right? So, right, now I'm coming to get the probability density function. So this you would have done in mathematics, factoring. Have you heard about factoring? Peony, have you heard about this factoring? Yes?
What is in Sinhala, sir?
Huh?
What is in Sinhala?
I don't know what is in Sinhala. But in mathematics, you have done this factoring. I will just show you to see the combination. In our example, how many 5 processes? So in this, out of 5 processes, getting 3 head. Getting 3 head in 5 processes. So x is 3. So here, this is how we write it. What are the possible outcomes out of 5? That is getting 3 as it, right? So this can be written as 5 as it is in the notes. So this is equal . Sorry. Getting 3 heads. So this is equal, right? 5 factor. Have you seen this kind of notation? Yeah. So I will put the formula first. N factor x factor into n minus x factor. This is right. So this is the actual formula. So what is n? What is x? So that is equal. We can write it. This is the formula. That we can write 5 factor divided by 3 factor into 5 minus 3. 5 factor mean 5 into 2 into, sorry, 5 into 4 into 3 into 2 into 1. That is how the factor is defined. So here we can, for this, we can say 5 factor is 5 into 4 into 3 into 2 into 1. That is your numerator. What is the denominator 3 factor? That is 3 into 2 into 1 multiplied by, multiplied by 5 minus 3. What is 5 minus 3? 2. 2 factor, that is 2 into 1. So you see here, this will cancel off. This will cancel off here. Right? So what is the answer? What is the answer? 10. So 10 times it occurs. So 3 heads occurring how many times? 10 times. So this is how we can find out factor. Okay. So this is how you do the calculation factor. So you have, I hope you have done in mathematics, right? So this is what we said factor. 5 by 3. Let's see. Yeah, 5. N is 5, X is 3. So there may be different ways to arrange. Doesn't matter. The arrangement is not matter. Right? Right? I mean, arrangement is matter. Arrangement is matter. So we can have, because we have 5 different processes now. So that out of 5, what are the ways that we can get 3 heads? So we can do it like this, right? So 10, the answer is 10. Do you know how the answer comes? Right. The factorial review, this is the formula that gives n mean, n factor mean, n into n minus 1 into n minus 2 into n minus 3 and so on. Right? We will complete this formula and then we will finish it. So then the probability density function formula gives probability into 3 heads and 2 tails. So our main objective is X is getting a number of heads. So 5, 3, factoring 5, 3 into probability of getting heads into probability of getting tails. So probability of getting heads is 3, probability of getting tails is 2 times. So if you multiply this, because these are same probability, half, half, take the value half, half. So half to the power 5. So you will end up with the half. Why it is half? Why it is half? So the probability of getting x equal 3 is equal factor of 5 and 3 multiplied by probability of getting head. Probability of getting head. How many times? 3 times into probability of getting tail. This is success and this is failure. Success and failure. So this is 2 times. If it is 3 times, this is 2 times. Altogether 5 times. So this is the formula that we can use. So that is equal. So the answer for this is 10. We have already found out the answer. What is the probability of getting head? 1 head. What is the probability of getting 1 head in a toss? Eating at
1 over 2.
1 over 2. Yes, 1 over 2 to the power 3. What is the probability of getting tail in a toss?
1 over 2.
That is also 1 over 2 to the power 2. This we can add, isn't it? Base are same, so that we can add the power. So the answer is 10 into half to the power. So if you multiply this, you will end up with the answer given there. The answer given there. So you will end up with the answer roughly about 0.3125. You will get the answer 0.3125. You will get the answer 0.3125. But if you get them in percentage, 31.25%. Okay. Right. Right. So similarly, you can find out the rest. 0 number of it, 1 number of it, 2 number of it, 3 number of it, 4 number of it, and 5 number of it. So this is how the probability density function looks like. So when you look at this probability density function, this function, you see it is symmetric, isn't it? You draw it properly, it is symmetric. So this value is same as this value. This value is same as this value. This value is same as this value. So it is more or less symmetric. Symmetric distribution, isn't it? You know what is symmetric distribution? We discussed about this, right? The distribution like this. So cut here, it is same, half, equal half. So this is the number of heads. So this is the probability density function when you toss a coin 5 times. So if you put up the values of x, 0, 1, 2, 3, 4, 5. So we have already found out for the value here, probability px, here 0.3125. Can you find out the rest? This, and this as a homework. And we will stop here. Right? Find out the probability structure. We will stop here because the time is up. Any questions? We'll look at the rest later, next time. Any questions?